Happy Friday, guys. Today you are going to continue to do what you did Wednesday, and you're going to write notes from this YouTube video and attach them on the Canvas page. That really worked well for a lot of you Wednesday, and hopefully you can figure out how to do that. I have changed a couple of settings on there, so hopefully make sure that you attach your picture of your notes to the Canvas page. I'll be putting those in as daily grades, so please make sure you do that. Today we're talking about horizontal asymptotes of the same 11 problems that you did on Wednesday. We will try graphing those on our paper, and then we're going to check our answers with Desmos. I think after we do a couple today, you'll kind of realize how to do it and do the whole process. We'll be checking all of these problems on Monday for the correct answers, so look for that on Monday. Now, just like on Wednesday when we talked about these graphs, the three characteristics that we talked about on Wednesday were finding the y-intercept, the x-intercept, and the vertical asymptotes. Today we're going to talk about a really important one called the horizontal asymptote. It's actually quite difficult to find just because there's just three different rules. Now, the rules are not difficult, it's just kind of hard to remember with all of it kind of combined together in one. In order to find horizontal asymptotes, it all has to do with the degree of the polynomial. Can y'all believe that? The degree. Yes, the highest exponent in the numerator and in the denominator. You're looking at the degree. That's the only thing you have to do to find the horizontal asymptotes. Now I'm staying still on this screen because I really want you to write these three sentences down. This is very important. There are examples there under them, but these three sentences are very important. We're going to go into these three different scenarios, and I'm going to give you an example of each and how you find the horizontal asymptotes for each one of these. Actually, two of them are ones that we'll work through in advanced algebra, and the third one is actually one that you would talk about if you were in your pre-calculus class or in an honors advanced algebra class. So we're not actually talking about having those types of horizontal asymptotes, but we stayed on this screen for a really long time because I really want you to write all three of these down. We'll talk about each one of them in just a second. Here is scenario number one. The degree of the numerator is less than the degree of the denominator. So you're literally looking at the exponent. Here, the exponent of this one is 2x plus 5. So the degree is actually a 1. If you look at the denominator, the degree of the bottom is actually a 2. So that means the degree of the numerator is less than the degree of the denominator. Now, when that happens, your horizontal asymptote is y equals 0. We also like to call that the x-axis. So yes, we have a place on the graph where the values are undefined. The graph will approach that horizontal asymptote, but will not ever cross it. Scenario number 2 is when we have the degree of the numerator equal to the degree of the denominator. You'll notice this is what I like to call equal degrees. So if you'll look at this problem right here, this problem says, you can't really see the 2, but it's a 2x squared. The denominator also has a 1x squared. Those degrees are the same number. So what that means is the horizontal asymptote is going to be the coefficients of those front two leading degrees. So to be honest with you, a 2 over a 1, that's why I have them circled. Because they are circled, 2 over 1 simplifies to a 2. So y equals 2, the horizontal line of y equals 2, and you'll just look at this graph right here, the horizontal asymptote is at 2. So literally, if their exponents are equal, the coefficients in front give us the horizontal asymptote. The third scenario tells us if we have the degree of the numerator that's greater than the degree of the denominator, then we actually have no horizontal asymptotes. They're actually called oblique asymptotes, and you'll find them by using long division. It ends up being something that we like to call a slant asymptote. Long story short, we're not required to go through it that far in the process. So this third degree, when the numerator, this is a 2, the degree is a 2. The degree of the denominator is a 1. So when the degree of the numerator is greater than the degree of the denominator, you would just write no horizontal asymptotes. Here's our first example. F of x is equal to 4 over x minus 4. We know this is a rational function because it's a fraction that has a variable in the denominator. Now, check the degrees. The degree of the top of the numerator is x to the 0 power, and then the degree of the denominator is a 1. Therefore, this follows along with what we called scenario number 1, where the degree of the numerator is less than the degree of the denominator. Immediately, horizontal asymptote, I put HA for short, y equals 0. Now, let's go over here to the graph. This is actually the graph of this equation. And you'll notice here, the horizontal asymptote is essentially y equals 0. Notice how those curves are approaching the x-axis, but never crossing it. Here, up here at top, if you could see it, approaching the x-axis, but not crossing. You'll notice on this second example, what's the degree of the numerator? I have the degree of the numerator is 1. What's the degree of the denominator? The degree is 1. You'll notice those numbers are the same. We call that equal degrees. So what we do to find the horizontal asymptote, when they have equal degrees, you take their coefficients. So the 1 in front, 1 in the denominator. So y is equal to 1/2. That would be the equation of the horizontal asymptote. So let's check that over here on the graph. The graph here shows there's a dashed line. There's a dashed line at a horizontal line at 1/2. So you'll see that right there. Example number 3, you'll notice what's the degree of the numerator? 2. What's the degree of the denominator? 2. So the coefficients in front, they're equal degrees, so the coefficients in front, a 1 and a -4. So y equals a -1/4 should be the equation of my horizontal asymptote. So let's look over here at the graph. You'll notice you can barely see it. It's right there below the x-axis, but it is definitely there at -1/4. For the fourth and final example, let's look at the degree. What's the degree of the numerator? 2. What's the degree of the denominator? 1. So in this case, this is actually our third scenario, where the degree of the numerator is greater than the degree of the denominator. That means that the horizontal asymptote, we would write the words horizontal asymptote and we would write the words none, because the asymptote that's going to be here is not a horizontal line. It's actually a slanted line, which we call, in this case, is going to be a linear equation. I just wanted to show you the graph and show you that it's actually not a horizontal line, but in this case, the asymptote would be something like this, and you actually randomly find this by using long division. We're actually not going to do that for this time around, but I just wanted to show you that this is not a horizontal line, therefore it's not a horizontal asymptote. Just to go back as a reminder of what you're supposed to do today, you should have written notes from this YouTube video about horizontal asymptotes. Now go back to those 11 problems from Wednesday and try to find the horizontal asymptotes. Also, after doing that, I would love for you to graph the x-intercepts, the y-intercepts, the vertical asymptotes, and the horizontal asymptotes now that you found it. And then potentially, if you can go to Desmos, put the equations into Desmos and see if you can kind of make it all make sense.